Afternoon, everyone. Last time we focused on the foundations of cloud data centers. Things like virtualization, modular hardware, autonomic computing, remote management, and high availability, and the importance of security. In other words, we learned how data centers are designed to be efficient, self managing, and reliable. Now let's move on one layer deeper and look at the actual building blocks inside a modern data center. The facilities, the servers, the storage systems, the networking gear, and advanced technologies like serverless environments and NoSQL clusters that makes the cloud so powerful. Facilities layout. Alright, let's step inside a modern cloud data center. These aren't just regular office rooms with few computers. They are purpose-built specialized buildings designed from ground up for one thing, keeping thousands of servers running 24/7. They are divided into functional areas. One area houses the racks of the servers, another handles the power distribution, and another handles the cooling and environment control. They even have separate spaces for staff so human activity doesn't disturb the control environments. Power and cooling are critical. These machines generate enormous heat, so you will see rows of industrial air conditioning, raised floors for airflow, fire suppression systems, and multiple power feeds. Everything is redundant, meaning if one system fails, another instantly takes over. That's how companies like Amazon and Google can promise near perfect uptime. Computing hardware. Let's talk about the actual machines. The workhorses of data centers are standardized rack servers. Picture tall racks, like bookshelves with servers stacked in neat rows. Then there are blade servers, slimmer and more modular servers that slide in a shared enclosure. Instead of each server having its own power supply and fans, the enclosure provides shared cooling and power. This saves space and energy. Most components are hot swappable, meaning if a hardware drive or a fan or power supply fails, a technician can pull it out and replace it while the other systems are running. It's like changing a tire while the car is still moving. That's the level of uptime that they are aiming for. Storage hardware. Data centers aren't just about processing, they are also giant vaults of information. Storage is handled with disk arrays, groups of drives that work together. They often use RAID, which stands for Redundant Array of Independent Disks. It splits the data across multiple drives, so if one fails, the system keeps working. Storage is virtualized just like the servers. Instead of thinking in terms of individual disks, administrator sees one big storage pool that they can carve up as needed. Advanced features include replication. Replication means keeping multiple copies, snapshots, and which means saving the exact state of the system for a rollback if there is any error, and cloning, duplicating in volumes. For long term archiving, some centers still use robot control tape libraries. Yes, actual tapes that get automatically loaded for backups. Old school, but it's really reliable. Storage models. There are two big storage models to know: SAN and NAS. SAN stands for Storage Area Network. Think of it as a high speed private highway that connects servers directly to the storage at the block level. This is great for databases that need super fast, low latency access. NAS stands for Network Attached Storage. This is a file level storage, easier to share across different systems. If SAN is like plugging your computer directly into a hard drive, NAS is like a shared Google Drive folder everyone can access. Both use redundancy to avoid downtime. It has multiple controllers, RAID protection, backup cooling, so even if parts fail, your data stays available. Network hardware overview. None of this works without a strong network backbone. Inside the data center, first you've got carrier interconnections. These are the pipes connecting the data center to the outside internet. Think of massive backbone routers, firewalls, and VPN gateways. Inside, you have a load balancer that distributes requests. If a million people hit Netflix at once, the load balancer spreads those requests across hundreds of servers. Then there is the LAN fabric, the internal network connecting all of these servers, usually running at 10 gigabits per second or faster. It's like the nervous system of the data center. On top of that, we have SAN fabrics that connect servers to storage and NAS gateways that let file based storage work smoothly. Together, these subsystems make sure that all pieces talk to each other seamlessly. Optical links and redundancy. Cloud isn't just one building, it's multiple data centers spread across regions. They connect to each other using fiber optic links. A key technology here is DWDM, dense wavelength division multiplexing. It's like putting multiple colors of light through the same fiber, with each color carrying its own data channel. This multiplies capacity without laying more cables. These links connect not just the servers but the entire sites. If one data center goes down, traffic reroutes to another. That's how Google search stays up even if the whole region suffers a power outage. Serverless computing. Now, don't let the name fool you or don't let the name confuse you. They are still servers here. The difference is developers don't worry about them here. In serverless, like AWS Lambda or Azure functions, you just upload your code and tell the cloud what it needs. The provider handles the rest. Runtime, scaling, or even failover, and the billing is per execution. You only pay when the code runs. This frees developers from babysitting servers and lets them focus only on writing features or building features. Imagine you run a food delivery app instead of managing servers 24/7. You write small pieces of logic like calculate delivery fee and the cloud runs them only when it's needed. NoSQL clustering. Traditional databases like MySQL or Oracle are relational. They store data in neat rows and columns, but when web apps exploded, these couldn't scale fast enough. That's where NoSQL came in. NoSQL databases run on clusters. Clusters are a group of cheap commodity servers working together. Instead of buying one giant expensive machine, you scale horizontally rather than scaling vertically. Just to keep adding more nodes will gain more power for these servers. This makes NoSQL perfect for apps like Facebook or Twitter that handle huge, messy, ever growing data. It's highly fault tolerant. If one node fails, the cluster keeps running. What's the trade off then? You don't always get instant consistency. Sometimes it takes a moment for all the copies of data to sync. But for many apps, speed and scale matter more than perfection. NoSQL features. NoSQL comes with some unique features. It's schemaless, so you don't have to predefine a rigid structure like in SQL. You can store messy JSON documents, logs, or user profiles directly. It follows base and not ACID. ACID means strict consistency where it's used in banks, but base means basically available soft state eventually consistent. In other words, the system that prioritizes staying online even if not all copies are instantly in sync. NoSQL is usually API driven. You interact with it using APIs or queries that feel like working with JSON, not complex SQL statements. There's polyglot persistence. What does that mean? Meaning you can use NoSQL alongside traditional databases. For example, keeping financial transactions in SQL but use NoSQL to store user activity and logs. Use the right tool for the right job. Other considerations: real life isn't perfect. Hardware becomes obsolete fast, usually in 5 to 7 years. So data centers are always cycling equipment that leads to a mix of old and new machines, which complicates management and security as well. This is huge. Centralizing data means one breach can affect millions. Even with firewalls, encryptions, and monitoring, the stakes are still high. Cloud providers invest heavily in security, but no ecosystem is 100% safe. And that's all for today's class. See you again on Thursday, 5:15. So we will go over how TikTok is working in the background. And see you tomorrow.